Now let's look at some applications for this part. So the first application, which is the cost equation. So here's one example. A small company that makes hand-sew leather shoes has a fixed cost, which means the cost at zero output, they did nothing, of $320 a day, like rental tools or something like that, the labor fees, right? And the total cost per day, which is 1,200 at an output of 20 pairs of shoes per day. So when they produce 20 pairs of shoes, then the total cost would be 1,200. We assume that the total cost is linearly related to the output x. So here the question is, we want to find the equation of the line relating output to cost. Write the final answer in the form of C equals M times X plus B. So here C is the total cost, X is the output of shoes, pair of shoes, and this is called the linear relation, right? The linear relation between C and X, C and X, C and X, right? So now let's look at the first one. When the output X equals 0, then the C cost would be $320 per day, right? So C and X should satisfy this linear equation. So let's plug into it. Then you will see 320 equals M times X equals 0 plus B, right? So this tells you that B is equal to 320. But this is not the end of the story, because we also need to find M, right? So we use the second condition. The total cost is 1,200 per day at an output of 20 pairs of shoes. So that means when X, this is the first part. This is the second part. We notice that the second condition tells you that when X equals 20, the output is 20 pairs of shoes. Then the total cost would be 1,200. We plug in this one into the equation, then you have 1,200 equals M times 20 plus B we just calculate, B equals 320, right? Now we can solve this equation for M. So the first thing is we subtract 320 on both sides, then we will have, this would be 880, right? Equals 20 times M. So we divide by 20, so this would be 44. So the slope is 44. So the cost and output relation is given by this equation, linear equation. C is cost equals 44 times the output X plus 320. So this is your answer. Another example about the cost equation. A car rental agency charges $200 per week plus 0.25 cents per mile to rent a car. The total cost C for the renting the car for 1 week and driving it X miles can be modeled by the formula C equals 0.25 times X plus 200. The question is, how many miles can you travel in 1 week for $325 dollars? So that means we know the C is given by 0.25 times X plus 200. This is the linear equation between the total cost and the x miles. So now we know the total cost is 325. How many miles it drive for this cost? So 25, so we plug in C equals 325 equals what? Equals 0.25 times x plus 200. Then we subtract 200. So this would be 125. So we divide by 0.25, right? It would be 500. So it's 500 miles. That means you need, if you drive 500 miles, then the total cost you need to pay for 1 week, you need to pay the rental agency for $325. Now let's look at another application for the linear equation, which is called the supply and demand. So in a free market, the price of a product is determined by the supply and the demand, right? So if you have the relation between the price and the supply, which is given by, for example, for this line, this is called the price supply relation. If you have another line which is called the price demand relation, so you can see if this is the horizontal line is the x-axis, which is the quantity of the products, and the vertical line is called the price, right? So you can see that there is a very important information, which is the intersection point. At this point, the supply equals the demand. That is the ideal case, right? And the price at this point is also the ideal price. So we give some name. This name, the point of this, the intersection point between the price supply curve and the price demand curve is called equilibrium point. We use another color. Equilibrium point. The price at this point, which is called the equilibrium price, So that is the y-coordinate of this point. The quantity of the product is called, at this point, is called equilibrium quantity, where the supply, the quantity of the supply equals the quantity of the demand. Like that is a very ideal situation. So this point is very important. So now let's look at an example. So in this example, the price demand equation, which is given by P1 is equal to 35 minus 0.1x. The price supply equation, which is given by P2, another price, equals 0.2x plus 20. So here in the first equation, the x here, this is the number of the units in demand. And here x is the number of the units supplied. So we want to find the equilibrium price and the equilibrium quantity. Okay, so in other words, we want to find the equilibrium points for these two straight lines. So from here, we discussion here, at this point, they share the same, what? They share the same price, right? Equilibrium price and the same equilibrium quantity. So we can actually so that means at the equilibrium point, this P1 should be equal to P2. They have the same price, and here this x is the same x as here. So now if P1 is equal to P2, then we have 35 is equal to, minus 0.1x. This is the P1 price at this quantity is equal to 0.2x plus 20. Then we solve for x, right? So here we want to isolate x. In other words, we want to move x to one side and the constant to the other side. So we add 0.1x on both sides. So we have 35 minus 0.1x plus 0.1x would be 35 only, equals we add 0.1x on the right side also, 0.3x plus 20. Then we subtract 20, so you have 15 equals 0.3x. So x is equal to what? So if we write x on the left side, so this is 0.3x equals 15, so x equals 50. So in other words, this is called the equilibrium quantity. So what is the equilibrium price? When x equals 50, what is the price? No, then you choose arbitrary equation, then plug in x, then you can find the p, right? If we have plug into the first equation, right? So this would be the price would be the 0.35 minus 0.1 times 50, right? So this would be 35 minus 5 equals 20. So $20 would be the equilibrium price. So the equilibrium point would be 50, 20. This is called the equilibrium point. Another example, a local race for charity has taken place since 1993, using the actual speed of the winners from 1993 to 1998. Mathematicians obtained the formula y equals 0.19x times x plus 5 to represent the relation between the number of years after 1993 and the winning speed, miles per hour. So y is the winning speed, and x is the number of the years. This is the winning speed. And this is the number how many years after number of years after 1993. So the question is, in what year is the winning speed predicted to be 7.28 miles per hour? Okay, so the winning speed is 7.28 and 0.19 times x. X is the number of years after 1993 plus 5. So we want to know how many years after this 1993. So this one is, we subtract 5 on both sides, then you will have 0.19x equals 2.28. So if you divide by 0.19, then you will have 12 years. So after 12 years, think 12 years after 1993, so this would be 1993 plus 12, which is 2005. 2005. In 2005, then the speed would be 7.28 mph in this year. Okay, so here the x is the number of years after 1993. So you need to add to 1993, you will get the year.